All right, so the history of logs. So, y'all did logs to review. I don't know that you always know why you do them or what the heck they are or anything like that, but so just quickly. A log function is another way to write an exponential function. We should know that much, right? They were introduced by John Napier in the early 17th century as a means to simplify calculations. They were rapidly adopted by scientists, engineers, and others to perform computations more easily and rapidly using slide rules and logarithm tables, because they didn't have calculators back in the day. But they still work and are still applicable, obviously, to us. So the present-day notion of logarithms comes from Leonard Euler. It looks like Euler, but it's Euler, who connected them to exponential function in the 18th century. So this is really what I wanted to get to right here. So log base 10 is called the common logarithm. I can't say the word. So if you see a log with no base, we know it's a 10, right? Okay. Has many applications in science and engineering. The natural log has a constant e. E is not brand new, right? We've talked about that in Algebra 2, as its base, and it's used widespread in pure math, especially calculus. And then the binary logarithm base 2 is prominent in computer science. So if you're into computers, then logs are going to be important in there for you as well. Anyway, you can read the rest of it. I'm not going to read all the rest of it to you. But again, some of you will find it interesting. Some of you just, would rather I didn't even bring it up. It's all good. Okay. So let's look at rewriting and simplifying the logarithms. And on your calendar it said evens. That's because what I'm going to give you today is, obviously you're just doing the evens. Alrighty, and this is going on page 87. I'm at 800%, which is probably not going to be. There we go. All right. Now, yours, you don't have the red, you just have the black. But, and again, this should be a review for you. But if I have a logarithmic function, okay, these are inverses of each other. We know that. We've talked about that yesterday. For the inverse, you exchange the x and the y. And then we rewrite it as an exponential b to the x equals y. Make sure that you understand that that is different than just rewriting the log, because I think some of us got that mixed up last time. This is how you get them to be the exact same thing, like a log, or the log is not the exact same thing, but the log to find the inverse, that inverse, that exponential. It's not that they are equal. If I am just trying to rewrite this log as an exponential, then it's b to the y equals x, okay? So that's how we get it, is just the inverse of that. When I switch them, that's why these two things here are the same. Like these two are the same, and these two are the same. That's just rewriting it right there. This is actually finding the inverse of that one. Okay? But this is the way you would write. This log is written this way as the exponential and so forth. Okay. We're good? I don't know if that's exactly how you saw that. That's what I think the on-level Algebra 2, I stole that from them. I don't know if that's exactly what you saw, but or have it in your old notes. All right, so some properties of logarithms. If I have all these properties down here that use b, m, and n in there, those numbers always have to be what? What do you think goes in the blank? Can you use negative numbers? Can you have a negative base? No. Can you take the log of a negative number? No. So b, m, and n always have to be positive numbers. Can you have a log base 1? The answer to that is no. So b cannot equal 1. Can b be a fraction? Yes, it can be a fraction. It just can't be 1. It has to be positive, which means it also isn't 0 or anything negative. Okay, so here is a set of properties that we have right now. Every positive number has a unique log with base b, every single number, right? And if I have log base b of m equals log base b of n, that's true if and only if m is equal to n. And that should make sense. I mean, algebraically, just like anything else, whatever you do to one side, you do to the other. So if I have m and n and I take the log of both sides, then it's still equal, right? So I'm not dividing by the log or anything like that because that doesn't make any sense. But if these two logs are equal, they have the same base, then whatever you're taking the log of has to be the same. Then log base b of b to the k is just k. So log, if the base and this right here match, that always just, kind of takes care of itself. But you also should know, and this is not on our notes until tomorrow, but if you have the exponent, what do I do with the exponent on a log? Then I bring it out to the front, right? So this would really be k times log base b of b, and then log base b of b is 1. That's why this right here gives you k every time. This right here is up here in an exponent, so b to the log base b of n, since those are inverses of each other there, you just get the n out of it. And then log base b of b is 1, and the log base b of 1 is 0. Okay, we good? All just basic. Again, those should be reviews. That is not a brand new thing, but something for you to refer to as we go through this. All right, so the first thing we're doing is we're just writing it in exponential form. It doesn't say to solve anything. We're not solving it, right? But the base of the log always becomes the base of the exponent. All right, so it goes around like this. You got to take that into account. So 10 to the negative 2 power equals what? 0.01. Like I have all the pieces there. I'm not actually solving for anything. I'm just rewriting it. 10 to the negative 2 equals that. Piece of cake, right? And we did that to be able to graph too, to be able to get our little t-charts. All right, so here I'm going to take this and I need to rewrite it in a logarithmic form. So if I have an exponential, then the base of the exponent is the base of my log. So this is going to be log base what? 5. Okay. And then I've got to have something on the right-hand side of my equal sign and something right here. What goes on the right-hand side of my equal sign? The negative 1/2. Okay. This is just the opposite of what I just did. And so then this is the square root of 5 over 5. Everybody good? Just one way or the other, being able to rewrite them. Okay, so when I'm going to simplify them, means I'm probably going to be able to get some sort of number here. Now this is an expression, but in order to simplify it, I have to change it to an equation. So anytime you don't know what something is, you can use x. The rule actually says to use k. I would suggest using k because sometimes there's x's in the problem, and then that just might be more confusing once other things happen. So we're going to take this and we're going to set this equal to k. Right? So then I'm going to rewrite this, and I'm going to have 7 to the k power equals what? 1 over 49. Okay. And then just like you did on the homework that we just turned in, or some of y'all turned in earlier, we got to get the matching bases. So my matching base is going to be 7, right? So 7 to the k, this would be 1 over 7 squared. How do I get 7 in the numerator? Negative. So this would be 7 to the negative 2 power. So that tells me that k equals negative 2, right? But it didn't ask me to solve for k. It said to simplify the logarithm. So then we do this. I'm going to give you these 3 little dots and a little triangle. Do we know what that means? Y'all ever seen that before? Okay. So that's some notation that shows up in things. This right here, all that means is therefore. Okay, so we did all that stuff. Therefore, my conclusion is that the log base 7 of 1 over 49 equals negative 2. I'm kind of surprised y'all haven't seen that in science. Y'all don't do that in physics? No. We good? Good job. All right, so then I want you to simplify this next one. Yes, you would have to, so since it's an expression, you got to set it equal to k so that you get an equation and then be able to solve it from there. That's fine. You went over the top instead of the bottom. It's the same thing. I went like that and you went like that. It's the same thing. Yes. Oh, yeah, sorry. All right, so I want to know how to rewrite this as in exponential form. Huh. All right, so Yadiel, how would I rewrite this in exponential form? Okay. And then what? Okay. Very good, thank you. Log base 5 of the square root of 5 equals 1/2. Okay. Everybody okay with that? Easy enough? If you could do that worksheet, which most of you knocked out pretty quickly, even if you didn't turn it in before you left on Friday, most of you got most of it done or at least felt comfortable with it, so that's good. All right, we all good? Yes, sir. Oh, I did. There's something wrong with I turned my ringer down at some point. I didn't turn it back up. I halfway thought I heard it, but... all right, Evelyn, can you help me through this one? How would I'm going to set this equal to k, and then what do I do? Okay. 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 All right, so we were here. So 3 to the 2, what? Okay, okay. Those 3 to the 1/2. Okay. One. Y'all agree with that? Yes, and it would be fine to do it in this step, and I think that's what she was about to tell me, and I wrote the 9 because my brain was somewhere else. So, all right, awesome. Bye. So then, therefore, what do I write, Evelyn? Plus 1. Okay. Do you agree with that? Yes? We have questions? Okay. You got 1/4? Okay. Oh, because you're dividing, not multiplying. I'm over here going, yeah, that's right. Yeah, no. Okay. I was just totally agreeing with her. Yeah, that's right. And, all right. I don't know where my brain is. I can't even. So let's go back here. Let's figure out what happened. What happened is what happens to some of us, sometimes myself included, when you see two things like your brain, you're like, oh, 2 and 1/2. That's easy. That's a 1, right? But when you're solving for k, you're actually dividing both sides by 2. So 2 divided by, or sorry, 1/2 divided by 2 is the same as 1/2 times 1/2, and it is 1/4. Yeah, because 1 doesn't make sense. And I was kind of thinking that as I was writing it, like I don't really understand why it's 1, but it'd be 1/4. That make sense? Okay. Thank you. Always ask. But when I said, do y'all agree with this, didn't y'all say yes? No? Oh, I wasn't listening. You were talking about it going, I don't know. I don't think we do. Okay. All right. Are we good now? Thank you. All righty. Now we're going to simplify this one. So I'll give you a second to do, let's see. Yeah, go ahead and do this one. We'll do the next one together. All right. Demi, what do I write? Okay. Huh? Were you not done or what? Oh, that's fine. It's okay. So let's just talk through it together. It's all right if you're not done. So we've got what? So the left-hand side is going to stay the same? So we're going to use our base as 1/3, right? So we're going to get the 81. That means it's going to have to get in the denominator. So we know that this is going to have to be negative, right? Okay. But you can still just think about the 3 and the 81. Easiest way to me is count it on my fingers, right? 3 times 3 is 9. Is 81. Because 3 times 20 is 60, right? And then 3 times 7 is 21. Does that give you 81? Yeah? Okay. So, that makes sense? So then it's -4. By the way, if y'all don't multiply like that, you need to. right? If I'm going to do like 3 times 27, and, you know, I can't even write a 3. Don't come over here and do like long, you know, multiplication and carry the 1. Just do it in pieces. 3 times 20 is 60. 3 times 7 is 21. You put them together, you get 81. It's way easier to kind of think through that way. All right, so good. So now we've got k equals -4. Therefore, equals -4. Okay. So you can have a negative answer, but you can't take the log of a negative number, and you can't have a negative base. Right? Easy enough? We good? Awesome. All right, so let's look at this one. If I'm going to rewrite this one, this is going to give me 16 to the what? 1/2 power equals x. Is this super easy? What's 16 to the 1/2 power? 4. So x equals 4. And there's no therefore. I mean, it's just x equals 4. I was told to solve for x. I solved for x. Easy enough? All right, so you do the next one. Okay, now you tell me, does it help to rewrite this in a root type form, or is that good for you? Like, what do you do? You rewrite it? Okay. So if I rewrite it, then that means I'm going to get 9. What's the exponent on the 9? Is it a 3 or a 2? 3. And then the 1/2 makes it a square root, right? So that helps to rewrite it. Is that what most of y'all? Yeah, and that's good. That's good though. So do you have to cube it first? No. Could this be the square root of 9 cubed equals x? Do these two things mean the same thing? They do. So which one would be easier to do without a calculator or a whole lot of work? The bottom one, right? So what's the square root of 9? 3. And then 3 cubed is 27. You get the same answer this way, but your numbers are a whole lot bigger. So x is 27. So, you know, again, think smarter, not harder. Make sure that you know you could do those in any order because it doesn't matter. Okay? Are we all good with that? And if you need to do it in other steps or write some other stuff down, that's fine too. I just don't know that we all need to do that. Any questions? Awesome. So go ahead and glue that in. The worksheet I'm going to give you, you're going to have to do on a separate sheet of paper. I wasn't able to retype it because just something had to give. Do not try and cram your work on here. Okay? Yes?